I welcome Sven Lieber from Royal Library of Belgium, and he will present a project with his colleagues about data quality, where also MARC and mapping from MARC to other formats and representations is relevant. And because of the time, I'll just say, let's start.
Yeah, thanks for the introduction. So I will talk a little bit about data quality at the Royal Library of Belgium. So in this talk, first, I would like to give a little bit of context. So what is data quality even? What is correct? What is valid? Before I will briefly introduce current quality procedures we do at the Royal Library. And then I will talk a little bit about a use case, a specific research project, which also helped us to reveal some more subtle quality issues. Then I will present our developed librarian-in-the-loop workflow, and finally some lessons learned and future work from this project. The take-home message for this talk is use your data to achieve something, because you will likely encounter data quality issues when doing that. But let's first begin with what data quality actually is. So I brought you one example. You will see here just 2 book records. And as often mentioned, data quality is use case specific. So in these 2 book records, we just see some basic information about books and about the author and ISBN numbers. But let's give it a use case. Let's say we would like to know who the publisher was of these books. And we see in both representations that the information is there. So the quality of both records seems similar when viewing the records. If we go further and would like to know the use case where the publisher is from, and we look actual in the MARC data, we see that the data is stored in different MARC fields. So we know that here the publisher comes from the city Bruges, and we see the name of the publisher in a different field. Similarly, for the first record, we also get a MARC representation where we can see that the information is stored in a structured way. However, now we see that for this use case where the publisher is from, we see that the first record actually links to an authority record where more specific information about the publisher is stored, whereas in the second case, there's simply a text string. And the city Bruges, here written in Dutch Brugge, actually exists as well in France and in Belgium. So here the data quality is not sufficient for the use case of knowing where the publisher actually is from, and some human would be needed here. Also, with data quality, you might also think of incorrect data. So here's another book record where you see a book with an ISBN number. And if you check this ISBN number, which looks pretty fine, it is actually a valid ISBN number. But if we do some small changes in the second number here on the slide, we see this actually is an invalid ISBN identifier. And this is actually a mistake or like incorrect data we can detect based on some syntax rules. And there exists software to find that out. Now, if I just change a bit the ISBN number in this record here to a different one, which looks again like an ISBN number, and it is valid, it's a valid ISBN number, this ISBN number actually belongs to a different book. So this is now some sort of incorrect data, which is not apparent. It's not immediately visible that there might be a data quality issue. So there might be a human needed to check that. So this is what when I'm talking about data quality, what I mean. So now we'll talk a little bit very briefly about current quality procedures we do at KBR. So first and for all, of course, our librarians who receive books, who catalog the books we might receive via legal deposit, they add rich descriptions to the book in the MARC format. The tool they're using also supports already some automatic ISBN checks so that they have valid ISBNs, and they get notified what are the required fields so we ensure a certain quality. Of course, we also would like to be conform to the MARC standard. Therefore, we use the QA catalog tool from Peter Kerali, which once was extended for the KBR catalog. And every night, the quality is assessed. And as you can see here in this small graph, since we started to use the tool, we could enhance our quality with respect to the MARC syntax. Of course, we also would like to increase the quality of the existing data we have. So One important work is the use of standard ISNI identifiers. So ISNI is a standard name identifier and is increasingly used at KBR to describe public entities contributing to creative works. This is an ISO standard, and in 2020, KBR became an ISNI registration agency, just meaning that we can also issue and give out ISNI identifiers. As part of this procedure, we also had the so-called bulk load submission, which meant that we basically aligned our catalog with the ISNI central database. And with this initial mapping, 60% of our roughly 900,000 person authorities were immediately assigned an ISNI, and this number is now increasing as we are giving more ISNIs to the persons in our catalog. And last but not least, we also have different working groups within our agency for bibliographic information around different topics. To give one example, we have a URI working group. Because in Belgium, we have several languages, official languages. We also have a multilingual catalog. And if you, for instance, have the use case that you have an authority where you have to represent the information that this person was born in the city of Antwerp and died in the city of Brussels, you can use, of course, the mark field 370, but it might look like this in our catalog. So you see that the place of birth is written in the Dutch spelling, Antwerpen, but the place of death, Bruxelles, is written in the French spelling. And in order to increase data quality in this case, we can use the mark field, subfield $1, the real world object URI. But there we can see already that now it's ambiguous, like which URI belongs to which text. So that's why, for instance, this URI working group at KBR suggested that we might move to repeat 370 field itself to structure the information better. Now, as I mentioned in the take-home message, if you start to use your data for a specific use case, you might identify more subtle data quality issues. And this is now where the Belgians project comes in. It's a project I'm working on, which is about studying book translation flows. So basically, when was a translation of a book published? Who was the publisher of the original? Who was the publisher of the translation? And so on and so forth. And for the project, it is important that one of several key contributors needs to be of Belgian nationality. The book might be published anywhere in the world. We are focusing on different literary genres where different PhD students are working on. And we are focusing on the two main languages spoken in Belgium, so translations from French to Dutch and Dutch to French. And we're covering a specific time period important for contemporary Belgian history. So basically, what we did in that project was to develop a data pipeline. So for instance, we start with the KBR catalog, as through Legal Deposit, we have many Belgian book and book translations. But of course, it could be that some French-speaking Belgians might publish books abroad, for instance, in France. So we have to go to the National Library of France. Some Dutch-speaking Belgians might publish books abroad in the Netherlands, for instance. So we have to consider another data source. And there are many more other data sources relevant for literary translations or even some other databases like geonames. And that means that in the end, we have many different data sources, maybe all in different formats and with different quality. So what we basically did is we developed an automatic pipeline with different pre-processing per data source. For instance, a data source like the KBR record in MARC, where we use then the RDF mapping language RML to create RDF out of it. Other data sources might already provide RDF, which we have then to post-process in different ways. And then we would like to integrate all together in linked data so we can ask more sophisticated questions via Sparkle, for instance. And what we basically did then there, because the Sparkle queries became quite complex considering many data sources, we built our own database using same-as links, for instance, based on ISBN numbers for books, and based on several person or organization identifiers like ISNI for persons and organizations. And how this basically works, I will give you one example. So we see here 4 data sources from different national libraries, for instance, or ISNI registration agency. And these are all DAMs, which we mapped to RDF representations. And in this example, there are these 4 persons, which are actually all the same. But as you see, each data source provides different types of identifiers. We represented each of these data sources now in a different named graph within our RDF database. And what we basically do to integrate the data now is a Python script executing a series of SPARQL insert and update queries to build our database. So we start with the ISNI data as reference data, and we create a record for each found data in this ISNI dump, which is ISNI Belgians within ISNI. And then we create a schema CMS link linking back to the name graph source. Now, if we go now further, we don't do immediately an insert again because we would like to avoid creating duplicate persons. So now we do a series of SPARQL update queries based on the identifiers present in the data. So here we see that in this case there is no match, so we go further, and the data from BNF, as you see here, actually has a match. That means some certain information from BNF we add to our database, and we put a CMS link linking back in order for us to find some more information later on. And as you see here in the last example, there is a link based on the Wikidata identifier. So again, we add information we have in this data source to our database, so in this case the VF identifier, and put the same link back, same S link back. And as you see, based on the order of our integration now, this person at KBR is not linked yet. That's why we are performing a series of update queries depending on the number of data sources and types of identifiers. So the script will again go over, and now there will be a link found via the VF identifier, so we can also put a CMS link here. And only after this update rounds are complete, we can start looking into making another SPARQL insert query for all the authorities of the KBR record, of the KBR catalog, which do not yet have the same S link. And this is how we proceed through all the different data sources. So we end up with an aggregated view of the data, all integrated, and we have the same S links, which means that now we can use SPARQL queries to get our actual research corpus. For instance, where we can filter on the nationality, which has to be Belgian. And this is important because some data sources might not provide sufficient information like nationality, but others do, so we have to follow the links. Then we create a CSV or an Excel sheet, which can be used by our research partners, which are not necessarily RDF and linked data experts. And in this step, we create a CSV, which might look like this, where you see the different books. And then you can find more information about these books in the different sources. So in order to make a nicer view on the data, we can merge certain columns. And this is where we can also see subtle quality differences, because maybe now there's a different year of publication mentioned, which we found via a Python script. And this basically gave us the idea of actually comparing the data to look for data quality issues. And this is then where we started to develop this librarian-in-the-loop workflow, because humans are always important to fix such data issues. So basically how it works as an overview, we have this aggregated data, in linked data, and we can use SPARQL queries to provide a CSV to the librarian, having different columns where the librarian can look at the data and identify inconsistent data and provide the corrections back in a CSV format, which we then can use again to correct the data in our database, in the data source, if we are if we can access it, or we can notify then the maintainers of these data source if necessary. And to give it a little bit more formal context, there are several quality assessment methodologies out there, but just given this one here, for instance, in the second phase for the quality assessment, we want to identify quality issues and analyze them. And in this case, we defined several quality issues in our data, things which seem suspicious on the first glance. For instance, the conflicting dates you have seen. But to focus on a different example, something like duplicate identifiers. For instance, a person having two ISNI identifiers, even though there should only be one if it's not a pseudonym. And we can detect this issue after data integration. This is now a bit more general, more like a type of issue. So we also went and created different, more specific issues, and we also encoded the way these issues can be detected. To focus again on this one example, duplicate identifiers, there are different SPARQL queries to create CSVs for the librarian to actually visualize the differences between records. How this might be look is something like that. So we see here one record from our database with our ID, the name it has, the duplicate identifier, and then the information we have in our different named graphs. And now we see here already that there are actually two persons mixed up here. And the librarian can identify here this VF identifier, which actually is a common identifier, which was actually the reason there was a link late made with our pipeline. So then in the third phase, the quality improvement, where we would like to fix the root cause and problem issues, what the librarian can do then is provide us a CSV, for instance, with the wrong information, and if necessary, even one with the correct information, which we can use to fix the data. Of course, it could be that there is a false negative. For instance, someone having two VF identifiers, that's not a quality issue. So it can also be annotated here that this specific combination of values actually is valid. So we can take this into account when identifying the issue with a Sparkle query, so we don't see the same error or something which seems strange again in the next iteration. So basically what we do then, we can use these CSV information and use again some RML mappings to create RDF. So such then we can do Sparkle update, so delete and insert queries to fix it in our data, ideally before we run our integration step, so the wrong links are not even being created. And as mentioned, we can then even fix the data at the source. However, in this example I have shown now, we only removed the identifier, for instance. So we fixed the pipeline, but we didn't really investigate the root cause, why this person had the wrong identifier. And to provide some preliminary quality results, which we, from the ongoing work we are doing here, in our corpus, we have roughly 13,000 translations and 6,300 person contributors. And they're like 60, around 20 people with conflicting birth or death dates. There's certain 87 books with conflicting publication year. But we also have seen for the quality issue with duplicate identifiers that there are several hundreds which have different duplicate identifiers. And of course, because of our integration, one duplicate identifier might lead that more things get mixed up, so it becomes a bit more complex. So there's also some overlapping here. Important here to mention as well, of course, conflicting dates. There's some dependency between the issues. So if there are conflicting births at one authority, that might be because there are two authorities mixed up. So we should first check the duplicate identifier issues. And of course, as mentioned, it might not even be an issue because it could be that two pseudonyms were linked. So for the last part of the presentation, I will focus on the lessons learned and future work from this ongoing work we're doing here. Our data integration pipeline relies on identifiers. So that means if there's no identifier in common, we cannot make links, and we would need more sophisticated entity disambiguation techniques, which might require even more librarians in the loop. We have seen that certain identifiers seem to lead to wrong links or contribute sometimes wrong data or insufficient data, but the pipeline is configurable. So we could say, for instance, we integrate all persons only based on ISNI, and we can do the same again, where we say we take ISNI, VF, and Wikidata into account, and then we compare the overlapping outcome. And of course, the pipeline does the heavy lifting. From these 3,000 contributors, we don't have to check all these 3,000 contributors, but the pipeline already shows us, based on a comparison, what seems suspicious. And of course, the fixing of the data, as I mentioned already, we fix only the actual integration, but to fix the actual root cause, we might have to go to the data source itself to fix it. For instance, if there's a duplicate ISNI and there is really a duplicate record, that needs to be fixed outside of our workflow. In case data fields, so the CSV the librarian gets doesn't have sufficient data to decide if something is wrong or like a good match, we can of course always adjust via Sparkle or Python. But we also have seen that instead of fixing the wrong identifiers, it might be useful that the human just decides this KBR ID is this KBR person with this ID, is this PNF person with this ID. And we use this as some hard links, which are excluded from our automatic integration with identifiers. And of course, fixing issues directly at the source. So we use our iterative approach, so we can always let it run with new data. And we have seen that fixing it at the source often is more quick, especially if you are in control of the source, like in our catalog. But of course, you have to use the most recent data, like the BNF data and the catalog, for instance, is always up to date, but the RDF dumps we are using, maybe not. So as on my last slide, for the future work, this whole workflow of data integration is also very useful for our legal deposit completeness. So again, it might improve the quality of our catalog because we have to identify all Belgian publications. So the workflow we can use as well to identify Belgian publications in other data sources, map it to RDF, identify Belgian works, and then check via ISBN numbers if we have these works already in our catalog, or if not, so we can acquire them if necessary. So thanks again, and use your data to achieve something, and I guess you'll find something.
Yeah, thank you for this insight. Now we've seen 3 different ways to transform a mark to RDF, but also 3 different use cases, and I'm sure that this is of use for others too, to have comparison. Now we have some questions. The first was very specific about the extent property, like how many pages, or it's one data file, one computer type. Do you also look into this field?
Sorry, which field was it?
Extent, so the size or the number of pages or files in some publication. Well, if you know about this field, if not, then
I'm not really familiar with that field, no.
Yeah, maybe you better answer this if you can look it up. Answer this later in the chat. So we come to more general questions. To which extent do human specialists check the same as queries for person agents?
Well, so what do you mean to which extent? So, I mean, mainly we have this automatic pipeline, as mentioned, that we get like these 13,000 translations we can see. And then afterwards, we try to check, of course, the data to see if the corpus seems right, if the overlap seems right. So then a human comes to check it. But also, as mentioned, we have just started to implement this pipeline. So we are also just in figuring out how to best use it.
So did you use some sample to test your procedure?
Yeah, so indeed. So the identification of these issues are basically just Sparkle queries, which we can execute on the most recent version of our integrated data, which we can automatically create. And based on that, we saw, for instance, these 200 issues with WVF identifiers, and we are right now still busy in looking in the actual root causes why the data actually has that, in order to fix it then as well.
Now, how many people at KBR are involved in this? Because yeah, as shown by you, it's easy with some technology to spot errors, but to correct it, it's some more work. So how many people? Yeah,
that's a good question. I think, I mean, there's no one full-time working on it. So this is this one research project where we would like to build this corpus and of course increase the quality of our catalog. But so far, I think something between 2 and 3 people are always in the loop to see, like to check the outcome of our newest corpus investigations and then update the data if necessary, or enrich information even, like nationalities we didn't have, people who are of Belgian nationality, but we didn't know it, and then we could enrich this information.
Yeah, then it was also asked, do you foresee creating work entities?
Yeah, that's actually also on the roadmap for the project itself, so for the Belgians project itself, because right now the integration is happening on a manifestation level. So at some point we also would like indeed to do such sort of a clustering in order to identify the actual expressions and then the actual works.
Yeah. Then the next question was partly already answered. Do you reach out to the original data sources to correct
Yeah, so far we are still in the phase of kind of really looking into the data and see what are the possible root causes. Like for instance, we have seen certain wrong links being made late because for instance, data source provides a wrong identifier, but then if we checked it, we saw that it was already corrected at the source. And that was then the issue because we just used an outdated dump, for instance, because we have certain pre-processing which was a bit too heavy for this public Sparkle endpoint. So we used RDF dumps. So we have a little bit of outdated data. But if we at some point really have identified really invalid data, we really plan to send a list in bulk to these maintainers.
Yeah. Do you store the provenance of the data to create the Spark?
So I mean, it's several stages. So because the pipeline we are doing, which is also in GitHub, by the way, which is a series of Python scripts which performs some pre-processing, for instance, extracting data from MARC, maybe transforming to CSV, then to linked data, and so on. So that's all there. And then within our linked data database, all the data is stored in different named graphs. So there we can annotate if needed as well. And for the loop part, for the quality part now, for instance, within these CSVs, of course, you can always add more columns. So you could say, this was checked by this person. So we add this as well to our RDF representation of, I checked this already, and we have the information.
Yeah. So then there's a final question, it's more general. Do you know of some vocabulary to assert data quality metrics?
Not really to assert, but there are some W3C. There's a data quality assurance. I forgot the name now. There is official vocabulary which is used to describe quality dimensions, quality issues. So it's really more to describe a bit more the problem sphere, let's say. And then you have to apply something to compute the correct data.
I think this general question is a good example to follow discussion in the MetaMost instance. So feel free for the audience if you watch this live to ask more questions or leave comments, have your own ideas. We already have some good discussion there. And right now, if you switch to MetaMost, there will be posted a link in the town square to a Big Blue Button session where we can all see each other and discuss and get an introduction. With this, I will close the session and we see you